A pleasant day to everyone living in this beautiful earth. Welcome to
Partition Channel.
Partition Channel.
Partition Channel.
Partition Channel. Hi guys, how have you been?
I'm perfectly fine.
Doing good, of course.
I'm curious.
Of what?
Have you heard the news?
What news?
A magnitude of 7.2 earthquake hit Leyte last November 12.
Oh, that. Yeah, I've heard of that.
5.2? That was so intense.
It really was. So, what are you curious of?
I am curious of why earthquakes happen. What causes them to happen?
Oh, have you already encountered the word plate boundaries?
Plate boundaries?
Oh yeah, I know that. Plate boundaries are the edges where two plates meet. Most geological activities, including volcanoes, earthquakes, and mountain buildings, take place at plate boundaries.
Exactly. Did you know that it has different types?
Really? What are those? I want to know what type of those generates earthquakes.
That is our topic for today's video. We are going to tackle all about types of plate boundaries. Y'all ready?
Yes!
Yup. Yup.
Of course.
You'll surely learn a lot about this. Let's now start.
The first type of plate boundary is the convergent plate boundary. This is convergent plate boundary, also known as destructive plate boundary, an area on Earth where two or more lithospheric plates collide. One plate eventually slides beneath the other, causing a process known as subduction.
Convergent plate boundaries can cause collisions, extensive deformation of the Earth's crust, leading to a formation of volcanoes, the lifting of mountain ranges, and the creation of deep oceanic trenches. They are characterized by extensive earthquake activities. An example of this type of plate boundary is the Nazca Pacific convergent boundary in Chile and Peru. There are three principal types of convergent plate boundaries. Those are oceanic to continental convergence, oceanic to oceanic convergence, and continental to continental convergence. Oceanic to continental plate boundaries are characterized by a mountain range where the continental plate lifts up over the subducting oceanic plate, bordered by a deep subduction trench on the side of the oceanic trench. Oceanic to oceanic converging boundaries result in the creation of undersea volcanoes. And continental to continental convergent boundaries are often characterized by mountain building events such as in the Caledonian Orogeny, which brought the British Islands together.
The second type of plate boundary is the divergent plate boundary. It is also known as the constructive boundary. A linear feature that exists between two tectonic plates that are moving away from each other. Along these boundaries, earthquakes are common, and magma, a molten rock, rises from the Earth's mantle to the surface, solidifying to create a new crust.
Divergent plate boundaries within continents initially produce rifts, which eventually become rift valleys. They also form volcanic islands, which occur when the plates move apart to produce gaps that molten lava rises to fill. When a divergent boundary occurs beneath oceanic lithosphere, the rising convection current below lifts the lithosphere, producing a mid-ocean ridge. A classic example of this type of plate boundary is the Mid-Atlantic Ridge. The ridge is a high area compared to the surrounding seafloor because of the lift from the convection current below. A frequent misconception is that the ridge is a buildup of volcanic materials. However, the magma that fills the fissure does not flood extensively over the ocean floor and stack up to form a topographic high. Instead, it fills the fissure and solidifies.
The last type of plate boundary is transform plate boundary. It is also known as conservative plate boundary.
This plate is also known as conservative plate boundaries because they involve no addition or loss of lithosphere at the Earth's surface. This plate also is where two plates sliding past each other. As you can see in the model, natural or human-made structure that across a transform plate boundary are offset, split into pieces, and carried in opposite direction.
Transform fault boundaries are known for powerful earthquakes as the jagged edge of passing plates easily lock in place, building up pressures until the land gives way in a mass movement. The most famous example of this type of transform boundary is the San Andreas Fault in California. Energy release in these moments causes the earthquake. As a general rule, the longer the time has passed between earthquakes, the more powerful the next will be, as the mantle convection driving plate movement never stops, even though the plates may. A few characteristics you can use to identify a transfer plate boundary are small linear scars or valleys. These landscapes are limited to linear scars or interesting features where stream beds, roads, or other features are separated from each other as they cross the boundary. Transform boundaries characteristically have few obvious features and thought to identify.